Today we are going to learn about queue data structure and its implementations. Here queue is a linear data structure. Queue is a linear data structure just like stack, queue, arrays and a linked list. Okay, here what is the property of queue? Property of queue stands for FIFO. FIFO stands for first in, first out. First in, first out. You already know about the stack property, that is the first in, last out, otherwise last in, first out. Okay, just like the stack also having the property, here also queue having the some particular property of first in, first out. Nothing but which is first inserted into the queue, that will be removed at the first. Which is last inserted, that will be removed at the last. Here how can we insert and how can we delete? So by using the two ends we can insert and delete the elements, but in the stack we have only one, that is at the top end we can insert, and the same time by using the top also we can delete the element. Here we have the two ends. Okay, before that we have to see the small picture representation of a queue. Here look at that, all the small green boxes stands for some allocation here. So here queue insertion and deletion happens on different ends. One is rear end, and last look at, see there, front end. One is rear end and one is front end. So and next we can see the NQ, and the last is the DQ. What is NQ and DQ? Suppose if you want to add an element, nothing but if you want to insert an element, that is by using the NQ operation. Okay, NQ operation. So we have to check that if all the size is filled, is it overflow or not. Okay, next DQ operation. What is the DQ? If you want to remove an element from the stack, if you want to delete an element from the queue, that is called as the DQ operation. So here also we have to check, if nothing inside the queue we cannot remove anything. So while we are inserting and deleting, we have to check the conditions of overflow and underflow conditions. See what are the rear and front ends. What is rear here? Here rear is the get the last item from the queue. So if you want to insert an element by using the rear, we can push the elements into the queue. So by using the rear end we can insert the element into the queue. So here let us take an example. Suppose if the passengers make a queue before taking their reservation. So suppose if there are 10 passengers to stand in the queue to take a reservation, who is first in the reservation queue, he will take the first reservation, he will move from the line, that queue. So who is the next, he will take the next reservation. Up to the 10th person he will take the reservation and he will come out the queue. So just like who is standard in that first in the queue, he will take the first reservation. Who is the last, he will take the last reservation. At the same time some consumer product resources allocation also, this is done by the first service who is in the first in the queue. Okay, just like that. So here rear is an end to insert an element into the queue. So front is an end to delete an element from the queue. So front is the get the front item from the queue. Get stands for the front, stand for the get the front item. So rear stands for the get the last item. So rear is an end, by that we can insert from the front, we can remove the element. So by the rear we can insert, from the front end we can remove the element. So if you are inserting by using the NQ operation, so by using the DQ operation we can see the remove an element by using the DQ operations. These are the basics of the queue. So what are the applications of the queue? Look at these operations existed in the queue. So in the queue sometimes we no need to use the particular resources at times, so we have to keep in the some queue, so waiting state, these kind of situations. So look at the example, queue used when things do not have to be processed immediately. So if things are done by using some little while, taking some while, so by using this we have to use the queues, but we have to be processed in the first in first out order, like Bethware search. So Bethware search is a search, some of the elements has to be wait, so no need to process immediately. So one more thing here, when a resource is sharing among the multiple consumers, so suppose any resources, any hardware devices, anything, those are shared by the particular number of consumers. So the example, just like what is an example, including the CPU scheduling, disk scheduling, all these will be done by using the queue. So scheduling stands for some of the elements has to be wait in a queue. So we already discussed in the thread handling, just like they take an assumption. So some of the resources no need to work at this particular point of time, so they have to be wait. So but the waiting state will be done using the queue. So when the data, next one, when the data is transferred asynchronously, and nothing but, so data necessarily received the at the same time at the send, so between the two processors. So two processor using, so when the data is transferred asynchronously, examples take then example IO buffers and pipes, file and etc. These are the basic applications of the queue. How can we implement? We can implement by using the arrays, and we can implement by using the linked list also. Okay, these are the basics of the queue. So one thing we have to remind, so by using the enqueue we can insert an element, by using the dequeue we can remove element. So which end we can insert? By using the rear end we can insert, from the front end we can remove an element. So just like stack, we have some flexibility of taking element from the one end and remove the element from the one end. So like that it is easy to process. Suppose I want to check the what is the first element, I can check. If I want to check that last element, I can check. Beyond that, in the stack we cannot see the what is the first inserted. So by the stack only we can see only which is last element. We can seek only on the top of the element, we can seek the top of the element. So just like that we have the property. So one more thing we have to remind that, so while we are using the insertion we have to check that, so if our data structure queue is free, then only we can insert an element. Okay, suppose our queue size is some 10, so 0 to 9th position. Suppose if you want to add the more than 10, we cannot insert because it is an overflow condition. Suppose if you want to remove an element, that is nothing but dequeue operation. Suppose I have the 10 elements are removed, so nothing but our ends are, our front end, nothing but no elements existed here. So that case we have to specify that we cannot remove any element, nothing but dequeue stands for the underflow condition. So insertion, deletion, these two conditions will be checked. So full of the size, full of overflow condition and underflow conditions. These are the basics of the queue data structure.